Okay, welcome to part two of polynomial sketching. Really, part two is just some examples that we're going to go through. So we've already done the notes. These are a couple examples I want to walk you through a little bit. So let's get right down to this. Looking at the first one, you're going to get different forms for examples. Notice that this number 5 here is in standard form, and this one here, 6, is in factored form. I don't know, FF for factored form would work pretty well. So it doesn't matter what form you're going to get. You're going to get some version of one of these forms. You may have to change to it. But let's walk through these really quickly, and then we'll do one together, and then we got one massive one at the end that we'll do. So I'm not going to go through every step, but here to get this into the pieces of information we need, the first thing you probably want to know that I would grab off of this, and I'm going to point this out, is I know this is a cubic term, I know that this is a quadratic term, I know this is a linear term, and there was no constant. So if there's no constant, it means it's plus a 0. So what you find out from that right away is that your y-intercept is 0, 0, because your constant in standard form is your y-intercept. So from there, you could also get your leading coefficient. So that's where these two pieces come together. Let's grab a different color here. Your leading coefficient being this here is going to tell you a couple pieces of information as well. Your leading coefficient is positive because there's no value there that's negative, so it's positive. And you can also find out that it's an odd degree. So you're going to find out that it's odd, which if you get those two pieces of information, it should tell you your end behavior. Odd and positive, again, that's something that you're going to memorize. Starts low, ends high, or remember that it's odd and positive. It should on the right side go up, and they should be opposite, so the left side will go down. That was from our notes. Also from that piece of information up here being the lead coefficient, you're going to be able to tell the number of turning points. From that, it's always one less than the degree, so your maximum number of turning points is 2. Doesn't mean that you'll necessarily see them if there's some form of multiplicity, but you can have a max of 2. So to get the last two pieces of information that you need, which is your zeros, you're going to go ahead and have to factor that and find your multiplicity. So you're going to have to factor this out. So GCF'd it first, that's the first step. Went ahead and factored that. I come down to this, x plus 2 linear factor times the quantity of x plus 2 linear factor. That means x plus 2 squared. You must do this because that's how you find out what your multiplicity is. So don't leave them separate, or at least account for it if you do. So you find out that you have two zeros. You would solve for that. X equals 0. That's your first 0. Check. And then x plus 2, set that equal to 0. Zero product property, right? Solve for that. That's your negative 2. Check. And that one has a multiplicity of 2. So you know a couple other pieces of information from that. You know that your first 0, that is an odd degree because it doesn't have one, right? So it is going to, I'm sorry, yeah, it's an even degree because it's an odd. 1 is an odd degree, 0 technically counts as an even, so that's a touching or bouncing 0. And this one has a multiplicity of 2. I think I did this one wrong. I was going backwards on this. I'm actually right the first way. This one here being 2 should be an even, which is a bouncing 0. Let me correct my sketch. I was working from my sketch, which is negative 2, so that's your negative 2. This should be a bouncing 0, so I know that it bounces off of that. Actually, I don't know if it's on the top or the bottom. Let's do my end behavior again. So it should be coming in like this. It should be coming out like that. This one's going to have to be a bouncing 0. The other one's going to have to be a crossing 0, so it's actually going to reverse my sketch. All right, well, I didn't intend to do that whole problem, but we did, so that's a pretty good review. This one's similar to that. Again, all the same pieces of information, except for in this one, you're in factored form. The only note I'm going to make is that you have to, one of the ways that you can find your y-intercept, in this case plus a 0, is to multiply it in standard form. Or, if you're super smart, you remember that your y-intercepts always have a 0 for the x-coordinate, so you could plug in and solve for f of 0, find out whatever that value would come out. In this case, it would come out to be 0. That's how you could find your y-intercept if it's not in standard form. But everything else comes from it pretty quickly and easily. And if you're worried about your lead coefficient and the actual degree so that you can find your turning points, or if you want to know that it's odd, you can take just the first coefficients and multiply them out, and that'll tell you what your degree is, because eventually that's going to make your lead coefficient x times x times x. I mean, if this was 2x, then it'd be 2x cubed. If it was some other values in there, you'd multiply those. But for intents and purposes of finding your lead coefficient, just multiply all the first coefficients of your linear factors. There's your lead coefficient. All right. let's go ahead and walk through this one here. Actually, you know what? This one's pretty much the same as this one here. Again, you're going to factor, so I'm not actually going to do that one. We're going to jump right to the last page of the notes, and we're going to talk about this big one here. I'm not going to make you, I'm not going to write it down as I go, but I'm going to kind of talk about it. I think your notes have already made the correct change here, so a little bit of a change to our polynomial there. So it asks to find all the critical information, or critical points. Again, information is probably a better term for that. Of the polynomial x to the fourth plus 4x cubed minus 4x squared minus 16x. And again, if you need to, add a 0 there so you can see your constant right away, which should take you right straight to your y-intercept for that piece. Next part, what's the degree? Well, you could say 4, but we're more concerned with the fact that it's even, so it's a fourth degree, so that's going to give you your even. What are the maximum number of zeros possible for this? Again, zeros, not turning points, and those zeros can be, maximum is going to be 4, whatever the actual degree is. Okay, so pulling pieces of information in with the goal here to graph at the end. The effects of the leading coefficient, well, it's positive and it's even, so you can write that down, positive and even. And that means that even, they go the same direction. Positive means they both go up. So hypothetically, that's what those arrows mean. Oops, that's actually where it goes. This leads from the notes where the right side goes to infinity. You don't need to know that. The effects of leading coefficient mean that it's positive, that they're going to go up. I'm not too concerned with this. It's just one form of the terminology. So if you don't know that one or don't remember it and you remember it by arrows, as long as you understand it, I'm happy. So I think we've gathered all the pieces of information. The only part that we don't have would be the linear factors or the x to give us the x-intercept. So that's the part we'd have to go find. It is in standard form as it stands, so you would have to factor this, and you're like, Mr. Hallam, seriously? That's huge. Now, let's walk through this because there's little tricks that we can do with some of these larger ones, because all we really know how to factor is quadratics. And so sometimes we have to play games or tricks to kind of get things to work. So let's walk through this factoring here and see if you can keep up with it and see how this works. Because this is something that you will see in Algebra 2. You may see something, again, on ours a little bit like this. So again, first step in factoring is always to take a GCF. So and that's what the first stage is here. There was a common x between everything, which got me down to a cubic. That's pretty awesome, but I can't do much. Actually, I can do much with a cubic as long as one condition thing happens here, is that we have 4 terms to work with, because we're going to go ahead and do this by grouping, which is our technique that we use for quadratics. It will work for cubics here, but what you'll find is, so I made 2 terms, this term and this term, into its own group, and I made this term and this term into its own group, and then I GCF'd them. So what's common between x cubed and 4x squared? Well, there's an x squared, and that's x plus 4 left over. So what's common between negative 4x squared and negative 16? Well, I took out a negative 4, and you can see that if we're doing our traditional grouping factoring, you can see here that that's that common term between it. Notice our x is carrying down. It looks complex, but you ignored this x for now, right? And you just focused on the thing that you knew how to do, so it's not so bad. From there, you're going to GCF that term out, because that's the common term. So that's where it goes. It goes out in front, x plus 4. And then what's left over? X squared and negative 4. So you can see that we grouped that and factored it out. There's our x that dropped down the whole time. What you'll notice at this point, so we used our quadratic technique on it, where we usually get linear factors here, but you'll notice that we have one squared term left over. Awesome part about this is, if you remember what this means, ds, or difference of squares, or you can just go ahead and factor that again, because it's a quadratic. If you want me to write it out so you can see what it really looks like, this is what it would really look like. Let me erase that really quick. It would look like that. You could factor, actually should have an x there. There you go, 0x. But at difference of squares, first term's a perfect square and the last term's a perfect square, and it's a negative. You get to write them as opposite linear factors, and so we have. So when you're all said and done, this is something you need to be able to do. Your techniques that you have is all I'm requiring. No new factoring techniques. Just make sure that you're grouping at some point and that you GCF before you start. So to fill all this in for the graph, right, you would mark all your linear factors. You turn them into x-intercepts. So what are our x-intercepts? The first one turns into a 0, right? This one turns into negative 4. This accounts for a negative 2, and this accounts for a positive 2. There's no multiplicity with this one. Okay, so that means no bouncing zeros. just to kind of piece that together. These are all crossing zeros. Okay, so there's the rest of the information that we need. So we can start to tag this. You'd mark all your zeros first. You would know that they're all crossing. You'd probably draw in your end behavior next, which is up and up. So I'd mark those points. I'd draw my up and up arrow, because I know that that's what they have to do. And then I would go and start crossing my zeros. And it should cross between all of them. You can match your number of turning points. The maximum number of turning points for this should be 1 less than a degree. And since we have a degree of 4 here, we should have a maximum of 3. So I double check. 1 turning point, 2 turning points, 3 turning points. And we see all 3. So there you go. That's how you sketch a polynomial. It's all the notes back together. Just to review all of your critical points here, you're looking for the lead coefficient to leave you some good information. You're looking for your zeros, right? That's going to give you your x-intercepts. From there, you can decide with multiplicity if they're bouncing or crossing. And then finally, you would tie in your lead coefficient to your end behavior and find your y-intercept either by plugging in 0 for the x-coordinate or having it in standard form and seeing what your constant is. You put all that on the graph, and voila, you have a polynomial. All right, thanks for watching. That's not too long. We'll see you in class for the homework. We've got lots to talk about, so we'll see you there.